Hi, everybody. All right, we're on lesson 3 of statistics. Demonstrate an understanding of and the ability to apply the normal distribution. This is a long one. Sit back and get comfortable. All right, do you notice anything about all of these histograms that we have here and frequency polygons? Do you notice? Notice that they're all kind of the same shape. They're all what we call a bell shape. They're highest in the middle and they tail off towards the ends and the low end and the high end, and they're mostly symmetrical. This seems to be, it happens a lot in the real world, a lot of real world examples. I mean, this is birth weights of babies born to smokers and non-smokers. Notice the difference, you shouldn't be smoking. Heights of men and women. Yeah, men on average are taller, but there's not a lot of overlap. See how easy that was to compare when it was done as two frequency polygons? Yeah. Birth weight of lambs, height of something. I don't even know what that is. Probably, no, density, I don't know, but height of something. This happens a lot, okay? And the mean, median, and mode are all near the mean, okay? So these data sets that we are looking at in these graphs are what we describe as normally distributed. The curve is referred to as the normal distribution curve, the normal curve, or the bell curve, because it kind of looks like a bell. The normal distribution curve has some specific characteristics. The graph is symmetrical. Mean, median, mode are nearly equal and occur at the line of symmetry. And the line of symmetry is where you would fold it in half, like right in the middle. The curve is shaped like a bell. There's a peak in the middle, slopes towards the sides, and approaching zero at the extremes. And then there's some numbers. So, and you do need to know these numbers. About 68% of the data falls within one standard deviation of the mean. About 95% of the data falls within two standard deviations of the mean, and about 99.7% of the data falls within three standard deviations of the mean. So let's look at a drawing to see what that looks like. Looking at this curve, it's important to note that all of the data is under the curve. So under the area, the curve is constant no matter what shape the curve actually takes, and we'll look at that later. The area under it is always 1. So we said that 68%, approximately 68%, is within one standard deviation of the curve. So here we have our mean, mu, and then if we go up one standard deviation, we have 34% falls in there. If we go down one standard deviation from there, 34% falls in that. So the total amount from minus one standard deviation to plus one standard deviation is about 68%. And then the same thing, it bumps out from there. There's 95% between negative mu minus 2 sigma and mu plus 2 sigma, and about 99.7% within the three standard deviations, plus and minus. Okay. And where this 13.5 comes from is we have the 95% minus the 68% that's in this middle chunk, which equals 27. And if we go 27 divided by 2, we get 13.5. And then the 2.35% is, we know that there's 99.7% between this line and this line. And if we subtract the 95 that's between this line and this line, that equals 4.7%. And 4.7 divided by 2 is 2.35. So there's 2.35 on the top and 2.35 on the bottom, because of course the curve is symmetrical. And this normal curve is really useful Once you determine that a data set approximates the normal distribution, you can make, oh, hi Lily, you can make some reasonable estimates about the data, and this is where the stats become really useful, okay? The normal curves can vary in two main ways. One is that the mean determines the location of the center of the curve on the x-axis, and the standard deviation determines the width and the height of the curve. So because the area of the curve is always 1, and as the graph gets taller, it gets narrower, and you can go to this website and play around with that a little bit. I'm actually going to do that right now. I'll have to stop the video though and do it on a different video.